We are back once again for suffering. Today is day 124, and the video is going to be called Weekly Suffering 315 because the weekly contest is today, and we are due for an allotment of suffering. So, yesterday's video was called Fibonacci numbers, because the problem we were working on was a Fibonacci number problem, and there was a differential created by our performance. So it was just a diff. So the video is called Fibonacci numbers because all members of the hyperbolic coding chamber create a differential wherever they are present. Speaking of the hyperbolic coding chamber, you should join. Also, there was some pretty cool comments in the Discord. I was reading over the last few days. Someone called me the daily LeetCode guy, which is very, very funny. I don't know why that's so funny, but it's just very funny. Daily, I thought about making I think I'm going to change. The channel name may be changed to daily LeetCode guy, but we shall see. I also have some ideas for the Discord. Maybe I'll make a poll, and we'll see if we can make it make sense. But I have some ideas for the Discord that could be pretty cool, but it's going to require some code written, so I have to make some time for that. And then, so got to make sure that things make sense. Other than that, what have I been doing? I've been working on an application. Additionally, I've been reading and listening to a lot of the Indie Hackers website/podcast. It's pretty interesting. It is very interesting. I was listening to this woman talk about her startup, which was called Wish Tender. And it was very interesting. I didn't think there was going to be a lot of value to be extracted from the podcast, just because I think there are a lot much bigger like startup podcasts, but I've been browsing the Indie Hackers website for a very, very long time, so I figured I'd try it. And there was a lot of value in there, so I'd recommend, if you're interested in startups or making your own product, check it out. Hopefully it will lead us to the Holy Land, and if it does, we are going to rent a yacht and if we make it to the big leagues, we're all going to get sturdy upon this this aerobic this amphibious vessel. We will all get sturdy upon this amphibious vessel, and it'll be a pretty good time. And we're all going to, after we get started, we're going to do a LeetCode hackathon. So you're going to want to join the HCC for that. And as always, not a ton of things to say today. So today is day 124, and it's going to be called Weekly Suffering 315. Usually I do these contests at a relatively normal pace, but I'm going to try it in contest pace, and hopefully we'll just finish it. I honestly doubt it, but every contest so far we've made it a little bit further. So hopefully we'll spend less time trolling, and we're going to do a virtual contest, see how far we make it. I'm just going to jump into it. So we have an hour for today. Let us get to work. Also, make sure to join the hyperbolic coding chamber. It is a legendary coding chamber, and So we're going to set up the virtual contest. It looks like it wasn't very, very difficult because the finish time is about 6 minutes. And it looks like you get about an hour and 30 minutes. I also don't understand how a virtual contest works, so maybe we should read that sometime. So this is like an easy, let me make sure everything looks good on the screen. Okay. Given an integer array nums that does not contain any zeros, so you have an array of numbers that does not contain any zeros, find the largest positive integer k such that negative k also exists in the array. Find the largest positive integer k such that negative k also exists in the array. I think we see what they're saying. Return the positive integer k. If there is no such integer, return -1. So you have an array of numbers, right? and we have to find the largest number such that its inverse also exists in the array. So that number seems to be 3. We'd like to return it, otherwise we'd like to return -1 otherwise. So -1, 10, 6, 7. 7 seems to be the answer. We have both 1 and 7, the corresponding negative values in the array. 7 has the largest value, and their largest value would be 8, but none of them have an inverse. So that is what we would return. I think you could do this with sorting. Yeah, I guess the way I would do this, I would load the values into we'd iterate through the array, load the values into a set, and then that way we would sort the array, right, so that we could have the largest numbers first, and then what we would do is just start from the top and say, okay, we're going to check 7, we're going to check if its inverse exists in the array. If it doesn't, we'll go to the next one, and so on and so on and so on, and we'll just return whichever one whose inverse exists, and then from there, if we don't find anything that has an inverse, we would just return -1. So we'll try this one in TypeScript, and so we just need to load everything. There's no key bindings. Just gonna load everything in. So we'll just go plan it out. Set sort nums top to bottom, check if inverse exists. If so, return it. Otherwise, we return -1. So to load it into a set, let me just think. We just want to know if it exists. So create a set which is just going to store numbers and be empty to start. And I'm wondering, yeah, I think this is the best way because there could be ones that don't necessarily still have an inverse. So we'll take nums, we'll sort it, we'll pass it a closure, which should sort it based on ascending order. So actually, let's do it in descending order. From here, we can iterate const num of nums. Ah, man, my environment is still freezing based on returning. Then from here, we'll go from front to back, right, from largest to smallest, and we'll say if set.has -num, then we'll return num. I think this should work. Linear time and log linear space and log n time. So we'd load all these values into the set, right? So -1, 2, -3, and 3. We sort it in ascending order. So now we'd have 3, 2, -1, -3. So we start from 3, check if the set has -3. It does, so we'd return it. Then we'll check for this one, load it into the set. We start at 10. Check if -10 exists in the set. It doesn't, so now we'd go to 7. Check if -7 exists in the set. It does, so we'd return 7. We'd load all these into the array, into the set, sort the array, and then go from top to bottom, and then we wouldn't be able to find any inverses, so we'd return -1. Our answer is -1. That is the wrong answer. I just realized we didn't load any of the numbers into the set. Oh. So we get 3. Try the example test cases, and we should get 3, -1, and 8. 3. I said -1. Yeah, -1 and 7. So it looks acceptable. So we'll take that for now, and then we'll go to a medium. You are given an array nums consisting of positive integers. You are given an array nums consisting of positive integers. Positive integers only. You have to take the integer, take each integer in the array, and reverse its digits and add it to the end of the array. You should apply this operation to the original integers in nums. Return the number of distinct integers in the final array. So you're given a positive array. Take each integer in the array, reverse its digits, and add it to the end of the array. You should apply this operation to the original integers. Oh, I see what they're saying. To the original integers and nums. So the ones we add on to the end, we shouldn't actually. Basically, we don't keep going forever. Return the number of distinct integers in the final array. So we could do a version where we just do exactly what they tell us to do. Is this the reverse integers that were added to the end of the array are underlined? Note that for the integer 10, number of distinct integers in this array. I think there's another way to take a look at this problem. We could do a version. There's no Vim binding set up again. We could do a version where we literally do what we say. What they tell us to do. Versions do what they tell us to, or check rules for unique flips. So what are the rules for a unique reversal? For example, if you reverse single digit is the same. Let's double check that. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you reverse all of these digits, right, nothing changes. Now let's say you have 2 digits, so like 1, 3. Well, 1, 3. The digits reversed I think we don't have to. I think we can just do what they tell us to here. I guess maybe wonder what the constraints could be. Right, the num sub I is up to 10 to the 6th. So nums, 10 to the 6. 10 to the 6 is how many digits? 7 digits. So that'd be like 7 times 10 to the 5. Might not be the worst runtime. Might not be the worst runtime ever. So maybe we could just do that. The version I was going to do with checking the rules, we're going to have to treat it as a string anyway. So let's try the first one first. So we have to take each integer in the array, reverse its digits, and add it to the end of the array. I think we could also just use a set, so we don't have to actually add it to the end of the array. We could do is for each key of numbers, we can just reverse it, and we can return the number as a key, both forwards and backwards. That way we could say if we add 1, we'll add both 1 and the reverse of 1 to the set, because we have one unique number. We do 13, we'll add 13 and 31 into the set, which means we have one unique number. Of 10, we'll add 10 and 1 into the set, which means the distinct numbers we have would be 10. And then we'll have 12. Both 12 and 21 are new, so we'd have 5. And then we'll have 31, which is both two numbers, right? So you get 2 for these, 2 for, wait, huh? You get 1, just 3, 2 here. The resulting array is this. The reverse integers that we added to the end of the array are underlined. Right, so we have 1 for 13, we get 2 unique numbers, 13 and 31. Then we'll have a set. We only get 1 here, and then for 12 we get both 12 and 21, which would both be new. My environment has frozen once again. Okay, so we're just gonna try the do what they tell us to version first. And so the goal here is iterate through nums reverse num for each unique num, add 1 to output. So I think that would work. So to iterate through the numbers, we would say nums.each do num, that we have an n, and we want to have a set, which is just going to be hash.new, the default value being nothing. And we're going to need a function which we'll just call reverse, which will take a number, return a string. Let's say numster will be num 2s right, we'll split it by an empty string, and then we'll reverse it length minus 1 using the classic. Oh, I can't delete empty backspaces for some reason. we'll say temp is equal to numster sub left, and then numster sub right is equal to numster sub left, and then numster sub equals temp, and then from here we'll do left less equal 1 and right minus equal 1, and then we'll just return, or we'll do it in the Ruby way, numster. If we just write as the line, it'll automatically return the last line, so we'll do numster dot join as our return. And I just want to make sure that this works, so we'll put num sub 2. Oh no, we need to return it as a string. So it puts nums, we'll do reverse num sub 2. And then we'll just return 0 and just see if this runs. Going to comment this out for 1 second. Num sub 2 reverse is 0, 1. So maybe let me see if this works with num sub 3, which would be 0, 1, 2, 3, which should be 21. 12, we should get 21. So it looks like Ruby can't handle leading zeros. So we'll just say first non-zero will be equal to index 0. And we'll say while numster sub first non-zero equals 0. I think this is going to be a string because we split it. So do numster sub slice first non-zero going to numster dot length dot join to I. I don't know if Ruby has a slice method. Oh, we're supposed to use spread syntax. So we don't want to use slice, which is returning starting at the first non-zero index. What's actually happening is that starting at that index, we're going to return nums underscore string dot length elements. So I think we want is something like this, starting at first non-zero and going up to and excluding the last. Why is this so complicated? I'm just gonna print it and then also print what we get for printing that. Alright, we get 21. You get 0. You get 21. Oh, right. I'm looking at the wrong thing. This is working. I'm looking at the output. So I was looking at the wrong thing. So now if we set this back to 2 to give us 10, we should get 1. So we do get 1. Wait, or maybe this was already working and I was looking at the wrong thing? Oh man, it was already working. I was looking at your answer. We should have been looking at std out. So we wasted time. But we have each number. We get the reverse of the number. And then we'll say for num. And the reverse of that number that each do. This will be the inner num. We'll say if set dot has the key, right, for inner num, or if it doesn't have the key for inner num, what we're going to do is say ct equals 1, which is the number of unique elements. We'll just say ct plus equal 1, and doesn't have the key, we'll increment the count and then set inner num equal to true or something. I think we should just be able to do, yeah, we'll just use set num equal true and then we can return. I see. Yeah, I guess maybe we just, something about this format where the thing is switched over and my code comes at the bottom, just I didn't look close. It just was hard to read. So that's unfortunate, but I think it's good enough. The time complexity here would be the number of characters, I guess O of S, where S would be equal to the sum of the characters, the sum of the like the number, I guess it would be O of D, where D is the number of digits in the entire array, which I guess would just be linear time in another way. Linear space as well, I guess, because we're using it in a set. We have some of its number. Okay, so we have the sum of a number and its reverse given a non-negative integer num. Given a non-negative integer num. Return true if num can be expressed as the sum of any non-negative integer and its reverse. Return true if num can be expressed as the sum any non-negative integer. So I guess if they gave us 66, we would return true. Because you could do 33 reverse 33. So for example, they give us 443, which is positive, and then we'll return true. They want us to see if 172. Well, we know that if we do 172 plus 271, you get 443, so we can return true. 63 cannot be expressed as the sum of a non-negative integer and its reverse. We return false. 181 is true, so we have 141 plus 041 equals 181. Look that when a number is reversed, there may be leading zeros. I feel like we could just write what we just did before and combine it with another problem. Just pretty much go from 0 to n and just check if we can do the sum of the number and its reverse and see if we get the number. But I feel like we'd run out of time maybe, but I guess we could try it. So we create a function called reverse. It's going to just take a number and return another number. And to reverse the number, we can just turn it into an array, I guess. So we'll just turn it into an array of strings, and then we'll do, might be hard to see what I'm typing actually. Here we do let left equals 0, let right equals to numster.length minus 1, while left is less than right. Constemp equals numster sub left, and since we're saving left, we're going to replace it with numster sub right. And you can say numster sub environment has frozen is going to be equal to numster, actually just be equal to temp, and here we'll do left plus equal 1 and right. I don't remember if JavaScript can parse out leading zeros, but we'll just assume that it can. And then we'll have the reversed array, so we'll say numster dot join. I think it's just parse int. It's frozen again, and to test it, we're just going to return the reverse of the number. And we have to return true. So that seemed to be working for this one. I'm gonna try a custom test case with something like 440. See if we get 44. So we do get 44. So what we can just do is assume false, and we'll just do the range of zero up to and including num. Do I plus plus, and we'll just say if I plus reverse of I equals num, will return true. That's interesting. I thought we'd get TLE for something like that. But yeah, maybe we got lucky. This contest doesn't seem too bad. But I guess we could tell because the average time for the top players is like 4 or 5 minutes. So this might be the first one we actually have a chance to finish. This one is probably a hard. So it'll be interesting to see. You're given an integer array nums. You are given an integer array nums and two integers min k and max k, so 3 parameters min k and max k. A fixed bounded subarray of nums is a subarray that satisfies the following conditions. The minimum value in the subarray is equal to min k, and the maximum value in the subarray is equal to max k. A subarray is a contiguous part of an array. Return the number of fixed bounded subarrays. So return the number of subarrays where min value is min k and max value is max k. So min k is 1 and max is 5. One of those where that exists is here. The other one is here, which is 5. So this one we have 4 ones. Min k is 1 and max k is 1. Go 1 to 1, which is 1, 3. I'm not understanding how it's 10 though. So you'd have 1 to 1. Oh, actually, 1 to 1, which would be 1. This would be 2. This would be 3. Then we start here. We'd say this would be 1, 2. That would be 5. This would be 1. That would just be 1, 2, 3, 1, 4, 5, 6, and then I guess each of themselves also count, which would give you 10. Interesting. Sub I is greater than or equal to 1. Min k is always less than max k. The number is 10 to the 5th. It's important to note min k and max k can be in the same index. So maybe we could just iterate through the array and just always look for min k. If we find min k, we could do a for loop to basically visit all other max k's. So if we brute force it, you start at 1, go to 5, go to the next 5. Pretty much we just count every time we find max k. And then we try to find the next. Yeah, we just count every time we find max k. So we'd have 1, 2. If we go to this one, if we count every time we find max k, go 1, 2, 3. And also we'd add 1, 1, 2, 3. What if we just search for min k? We search for min k. If find max k increment. It seems like that would work for these first two cases. I can't imagine. The worst case time complexity, this would be pretty bad though, because we would do 1, do a whole array for it. Actually, it would be n squared. The worst time would be n squared. So maybe let's see if n squared passes. So we'll just have this. We'll just do this one in TypeScript. We'll just say ct equals 0. Let me make this here. We'll just return ct. And then we'll search for k as equal to 0. I is less than nums.length. I plus plus we'll say if nums sub I equals min k, all right, then we're going to want to do this for loop at the index basically to find all of max k. And then in here we'll say if nums sub we'll say I is, we'll change this to m. We'll say m is equal to I. So we'll also count the index that we start at. We'll say if num sub m equals max k, then we'll do ct plus equal 1. Seems to work for this one. Let's try the next one. We do get 10. Wrong answer. Output 7. Answer was 81. How does this not give you the answer? Two, 3, 4, 5. Right? And then the next time you'd find it, it'd be at 3504. You have 1, 2. So that's how we're getting 7. I think what they're saying is contiguous which means backwards also counts as well. If that's the case, I think we could just do m equals 0. I think it would give me the wrong answer when we have all of these. When we have them all being the same, but I think it. No, we still get the wrong answer. The expected answer is 81. $35.04, $94.34. I'm not understanding where they're getting 81 from. You are given an integer array nums and two integers min k and max k. A fixed bound subarray of nums is a subarray that satisfies the following conditions. The minimum value in the subarray is equal to min k. Maximum value in the subarray is equal to max k. Return the number of fixed bound subarrays. Oh, I think I see what they're saying. I was looking at it like it has to pretty much min max be 5, but you still technically have a new subarray even though the max hasn't changed and you include 2. Whereas originally I thought the fixed bound subarrays were 135 and 135,275. That actually doesn't even make any sense because that means the max would have been 7, so you can't go past. My question is, if we put 2 1s here, 1 and 1, 1, 1, 5, is this 2 subarrays? We have 1, 1, 5, 2, 7. No, we don't. We have 1, 1, 5, 2, 1, 1, 5, then 1, 5, 2. Would the answer be 4? 1, 1, 5, 2, 1, 5, 2, 1, 1, 5, 1, 5. Answer is 4. Forward only is good. we changed it so that instead of doing the whole array, instead of starting at m equals 0, I think we still want to start at m equals I. And then what we'll do is we can still count ourselves, and then every number that we can add, if I is less than or equal to k, but we need to find max k first. So we'll find max k, so we get to 5. Once we found max k, every number afterwards that is less than or equal to max k will be a new array, which will count 1, 3, 5, 2, and as well as 1, 3, 5. So when we start, we'll set found k equal to false, and as soon as we find num sub I equals min k, we'll make sure that num sub I, we'll set found k in the inner initialization to make sure that if num sub I equals max k, that we started at true, otherwise we started at false. Then we'll iterate starting at m equals I. And we actually can just compress this whole thing into num sub I equals max k. And actually, it might just be simpler just move it in here because it's the same thing. We'll change num sub I equal to num sub m. If it equals max k, we'll set it equal to if we haven't found k, then found k, right, is going to be equal to num sub m. If we haven't found k, we want to set it. Once we find k, we want to keep it set. So here we can say if found k and num sub m is less than or equal to max k, ct plus equal 1. 7 is not the right answer. Oh. And then as soon as it's greater than, we want to stop. Our answer is 0. No, we don't want to. Oh no. All right. If we found k already, and num sub m is greater than max k, then we want to stop. I think we're missing. Oh wait. I think we need to reset the cases. I'm pretty sure this is still wrong. Alright, so I don't think we need to run this case to know if the answer is true or not. We run a custom test case and just add more ones. Oh, I think I see what's happening. At the end of the for loop, we have to reset found k equal to false. Answer is even less now. This should probably be better renamed to found max k. So we try to find k first. Try to find k first. I'll try to find min k first. After we find min k, then we try to make sure that we at least found at least one max k. I think the problem with this is the reason it doesn't work is because it assumes that we always have to start with min k, and there are other subarrays that exist that don't start with min k. There are other subarrays that can start that don't start. So what if we just did the same thing we did for found max k, did it for found min k, what if you could just start, if we change the starting subarray to look less like this and more like this, where you replace 1 with 3 and 3 with 1. Start at 3, we haven't found min k or max k yet. So you have this one, then this one. Now we found them both. Since we found them both, as long as we don't find a new min or a new max, we should keep counting it as a new subarray. So we'll duplicate this. If we found min k and we found max k and num sub n is less than max k, right, and num sub m is greater than or equal to min k, then we do count plus equals 1. Otherwise, if it breaks either of these rules, it's a little more detailed than that. If we've already found both, if we found max k, if we haven't found max k, if both of them exist, I think it's if we found max k and this number breaks it, or if we already found min k and this number also breaks it, then we'd like to restart. And then we can reset both when we move to a new index. We still get 21. Oh, we have to remove num sub I equals. Got the wrong answer. Rip. 132, 118. It's like we have just a few more than is necessary. Which means we have one more case where we need to break. So we have one more case where we need to break. We could also compress this. Styling here is awful. I think we need one more case. If we found max k and it breaks the case, I feel like we might not even need to make certain that this is the case. I feel like if the number breaks either of the cases, it can't be. What is the issue? Line 21. Still get 81. I feel like for this one, I think we have it now. What is going on? I see. So it looks like it works, except for this last one, with infinite ones, the answer so I think we solved it. It just happens to be that n squared is pretty crazy. So it looks like we need a linear time version. How could we squish this for linear time? Rip. I think we're out of time and my computer is about to explode, so I think we're going to end there.